Good day everyone, today's video is about problem solving.
Clap.
Imagine you have this problem. A survey of university students revealed that 64 had taken mathematics, 94 had taken chemistry, 58 had taken physics, 20 had taken mathematics and physics, 26 had taken mathematics and chemistry, 22 had taken chemistry and physics, and 14 had taken all three courses. Determine how many students only took one course. Schoenfeld defines problem solving as finding a way out of a difficult situation or achieving a goal that is not immediately attainable. According to this viewpoint, one of the activities in which students engage is problem solving. Fortunately, George Polya took the initiative to address this problem through his four-step process. Number 1, understand the problem. Number 2, devise a plan. Number 3, carry out the plan. And number 4, look back. The first step is to understand the problem. Reading the problem once will not achieve a remarkable result, so it is recommended that you read at least twice. Sometimes the problem is in understanding the problem. If you are unsure of what needs to be solved, you will most likely get the wrong results. How would you know if you truly understand the problem? First, if you can restate the problem from your own perspective or level of understanding. You may think one way or another about the above problem. There are three courses offered: mathematics, chemistry, and physics. A total of 64 students took mathematics, 94 students took chemistry, and 58 students took physics. There were 28 students who took mathematics and physics, 26 students who took mathematics and chemistry, and 22 students who took chemistry and physics. Finally, 14 students completed all of the courses. How many students enrolled in just mathematics, chemistry, and physics? Second, can you figure out what is known about this kind of problem? Examine the problem and take note of the values or quantities that may serve as your given. You can represent or you can present the problem as follows: mathematics 64 students, chemistry 94 students, physics 58 students, took mathematics and physics 28 students, took mathematics and chemistry 26 students, took chemistry and physics 22 students, and took mathematics, chemistry, and physics 14 students. Third, is there missing information that if known would allow you to solve the problem? If a problem has two or more unknowns, you cannot give an exact numerical solution. If it does, you can probably resort to a variable solution. Based on the given problem, it is clear that the problem provides all of the information, implying that a solution is possible. Fourth, is there extraneous information that is not needed to solve the problem? When we say extraneous, means not relevant to the problem, so we don't accept them as solutions. Now, how are we going to find out? After you have gathered all of the information, take into an account whether it will help you solve the problem. In the above problem, it shows that all information is necessary for the solution to be carried out, so there is no extraneous information at all. Fifth, what is the goal? The goal in each worded problem is usually placed at the beginning, but is more likely to be placed at the end. You can easily identify it by becoming familiar with the following key terms: find, determine, compute, look, calculate, simplify, how long, how many, how much, how far, and so on. Well, in the above problem, the goal is to determine how many students only took one course. So, show this way. Let M, C, P represent sets of students who had taken mathematics, chemistry, and physics respectively. The required is determine how many students only took one course. The second step is devise a plan. When you devise a plan, you come up with a solution to a problem. You can solve your problem by constructing an equation, drawing a diagram, or creating a chart. How are you going to organize all of the information that will assist you in locating the unknown and its solution? Letter A. You can make a list of the known information as what we had earlier as follows. Mathematics 64, Chemistry 94 students, Physics 58 students. Took Mathematics and Physics 28 students. Took Mathematics and Chemistry 26 students. Took Chemistry and Physics 22 students. And took Mathematics, Chemistry and Physics 14 students. Letter B. As with letter A, remove extraneous information before retaining what is necessary or required in the problem. Letter C. You can draw a diagram, but it is always depends on the problem. You can present a distance problem as graph, an age problem as table, a mixture problem as drawing or figures, a geometric problem as this, a comparison problem using the Venn diagram, a possible outcome problem using table, and a graphing problem as plotting. Use the figures to help you understand the problem and find the solution. In the case of the above problem, we will use a Venn diagram to show the relationship between the courses Mathematics, Chemistry, and Physics. Letter D. If the problem requires pattern, you may try to solve similar but simpler problem. In the given problem, you can use two diagrams to see how can you figure out the number of students and then use the pattern to come up with a better idea to solve problem involving three diagrams. Letter E. Work backward. If applicable to the problem, start the solution from the last statement of the problem to the beginning and reverse the operation if the problem is about money distribution, sequence, or pattern problem. We can apply the work backwards in the above problem by plotting the numbers on the Venn diagram and in the order of the given quantity, which as follow. 14 at the last statement of the problem, downward to the given numbers such as physics is 58, chemistry is 94, and 64 for mathematics. Letter F. Guess and check. You may use this method when you do not know how to solve problem. The guess and check method includes make a logical guess, test your guess, adjust your guess based on results of number 2 until you are correct. Letter G. Write a representation. It is good when the worded problem requires one, two, or more variables to represent. Like, for example, in the number problem, let x be the first consecutive even number. Let x plus 2 be the second consecutive even number. In the above problem, you may represent it using small letter m, be the number of students who took the mathematics course alone. Letter C, be the number of students who took the chemistry course alone. Letter P, be the number of students who took the physics course alone. Letter H, using of formula. If it is a work-worded problem, then we will use this formula. For distance problem, for lateral area, if the problem can be solved using the Fibonacci formula, for the Pythagorean theorem formula, and so on. The third step is to carry out the plan. This is where you solve the equation you devised in the previous step. How? Letter A. Work carefully. Never overlook any information that could lead you to a wrong decision or wrong solution. In the above problem, putting numbers inside the diagram requires time and arithmetic so that you can insert the correct information that is requested by the problem. So how are we going to apply this to the problem? Let's use the diagram and drop all the other important information as follows. We're going to use the backward method. Let's start putting the important information from the last statement in the given problem. So we're going to put 14 on the middle part of these three circles. And since the next row is 22 students on the shared area on the chemistry and physics here, so we're going to subtract 14 from 22, and then we have now 8 students. Next row is 26 students on mathematics and chemistry. In this area, we're going to put 26 subtracted to 14, then we have 12 students. Next row is 28 students on mathematics and physics. So we're going to subtract 28 to 14. So then we have now 14 students. Next is we have 58 students who enrolled in physics class or physics course here. So we're going to put 58 subtract to 14 for another 14 and 8. Then we have this equation, and the difference is 22 students. Next is 94 students, the chemistry. Then we're going to put 94 here, subtract to 12, 14, and 8. Then the difference is 60. The same process as to mathematics that has 64 students. We put it here. So 64 subtracted to 12, 14, and 14. So we have this equation, and the difference is 24 students. This is how we manipulate the given on the above problem using the work backward method. So letter B, keep an accurate and neat record of all your attempts. Letter C, realize that some of your initial plans will not work and that you will have to devise another plan and modify your existing plan. The fourth step is look back. It is wise to look back when solving problems. Check to see if you use all your information and if the answer makes sense. If your answer is correct, make sure you write your final answer with the proper labeling. How? Letter A. Ensure that the solution is consistent with the facts of the problem. Letter B. Interpret the solution within the context of the problem. And letter C. Ask yourself whether there are generalizations of the solution that you could apply to similar problems. Well, based on the four-step process of George Polya, we were able to figure out the above problem. So, the number of students who signed up for mathematics, chemistry, and physics alone is 24, 60, and 22 respectively. This is how we present the four-step process by George Polya. Thank you and God bless everyone.